when you have to add the fractions, adding or subtracting fractions, you must have common denominators. So when you see that the problem is asking you to add, your goal is going to be, I need to get common denominators. And right now, these denominators look really complicated, so we are going to try to factor the denominators to see what we actually have. Now, use the space that you have to your advantage. I'm going to spread my work out a little bit. We have 4 over 3x to the third. Give yourself some space. I'm going to attach the plus sign to the x. And I need to factor that second denominator. How could I factor these two terms? What do those two terms have in common? 3x squared. And if I do 6x to the third divided by 3x squared, 6 divided by 3 is 2. X to the third divided by x squared is x. And then 3x squared divided by 3x squared is 1. Okay, now do you see how I attached that plus sign to the x? That's not really all that important when it's addition, but if we were subtracting fractions, it'd be really important for you to attach that negative to the numerator, to the second numerator. So whatever symbol is between the fractions, just attach that symbol to the second numerator, and that will make your life easier later on. Okay, it's very helpful when you do this in pencil because I notice that my second fraction has 3x squared. Could I rewrite 3x to the third so it kind of looks like 3x squared? 3x squared times x. I'm going to change this to 3x squared times x. That'll just help me see that I do have something in common in both of these denominators. Okay, colored pencils or highlighters or colored pens are very, very helpful for this. What do these two denominators currently have in common? 3x squared. We're trying to get the denominators to match. So we want everything in the first denominator to be in the second denominator, and everything in the second denominator needs to be in the first denominator. So what does the second denominator have that the first denominator needs? A 2x plus 1. So we're going to multiply in a 2x plus 1. But you have to multiply it both on the bottom and the top. So now, both of my denominators have a 2x plus 1. Do my denominators match? Why not? The first one has this extra x, so we need an extra x. And if we multiply the bottom by x, we have to multiply the top by x. Okay, now do my denominators match? They may not be in the same order. It's fine if they aren't in the same order, but they do match. Now look back at the review problem that we did yesterday, this 8/12 plus 9/12. Once we got denominators of 12 that matched, what would be your next step? You'd add 8 plus 9 to get 17. Would you add the 12s? Do you cancel out the 12s? Do you do anything with the 12s? No. So our denominators up here, we're not going to do anything special with those denominators. That's just simply going to be the denominator. The denominator is going to be 3x. And let's go ahead and multiply that x back in and make it 3x to the third, 2x plus 1. What we really need to do is this stuff, which is going to involve some distributing and some adding. So 4 times 2x is 8x. 4 times 1 is 4. Plus x times x, that would be plus x squared. Do you like how that's currently written? Why not? The x squared really needs to be first. So x squared plus 8x plus 4 over 3x to the third, 2x plus 1. Now, usually we're done at this point. Sometimes the numerator might factor, and then we could maybe cancel more stuff out. So we should at least take the moment to check. Think about what can you multiply to get 4. You can do 1 times 4 or 2 times 2. Would either of those pairs ever add up to 8? No, so we can't factor it. This is our final answer. Start number 5 on your own. Try to factor both denominators so that you can see what you have in both denominators. Okay, this is the factored form. The first denominator factors to x plus 1, x plus 3. The second denominator factors to x plus 3, x minus 3. A couple things I want you to notice. Notice that I put the x minus 1 from the first numerator in parentheses. It's just a good habit to get yourself into. I also attached the plus sign to the second denominator. And if you look back at number 4, we did the same thing in number 4. It was a subtraction sign, and we attached that negative to the numerator. So it's just a really good habit to make sure that when you have a negative, you don't use the negative incorrectly. What do the two denominators currently have that matches? X plus 3. So I notice that my second denominator has x minus 3. I need an x minus 3 in my first denominator. And don't forget, when you multiply the bottom by something, you have to multiply the top by something. Now it should be pretty obvious that your denominators don't match because one of them has 3 things, the other has 2 things. So our first denominator has this x plus 1. Our other denominator needs an x plus 1. Now that our denominators match, again, it doesn't matter what order you write them down here. Our next step is to do everything on the top. And you have to multiply stuff out before you add it together. So we need to FOIL x minus 1, x minus 3. You can do that full out and do x squared minus 3x minus 1x plus 3. Or you can use the factoring trick. X squared minus 4x plus 3. In the second fraction, we have to do positive x times x plus 1, so that would give us x squared plus 1x. What do you think we now need to do in the numerator? Combine like terms. How many x squareds are in the numerator? There are 2 x squareds. There's a negative 4x and a 1x. That would give us negative 3x. And there's a plus 3. Complex fractions are Chapter 7's evil way of saying, I'm going to take everything that you've learned about in sections 7.3 and 7.4 and make you do all of it in one problem. So, theoretically, you know how to do this. All right? So, here's how you would do this. Step 1, get common denominators on the top. Get that simplified down to just one fraction. Okay? Step 2, you would do the same thing in the denominator. You would get common denominators, add those 2 fractions together to get one fraction as your answer. So you would end up with some sort of fraction divided by some sort of fraction. Step 3 would be divide those fractions. Keep the first fraction the same, change the sign to multiply, flip the second fraction. So everything that we've learned so far in this notes packet, it's all in this problem. It's just a 3-step problem that takes up a whole bunch of paper. So theoretically, you already know how to do this, right? So we're going to save time by not actually taking the time to do it, right? Okay, let's move on. This is the first time that we are going to see rational expressions with an equal sign. If you see an equal sign, that means we are going to solve. And the reason that I decided to throw this in today You've been doing these kinds of problems since Algebra 1. You did these in geometry. You're used to these. These are fraction equals fraction, which basically means all we're going to do is cross multiply and solve. Let's start with example 1. The first thing that you need to remember, anytime you have multiple things in the numerator or the denominator, put parentheses around them. So 2 over x squared minus x equals 1 over x. We need to cross multiply and solve. When we cross multiply, we get 2x equals x squared minus x. When you see x squared and x in the same equation, your goal is to get one side equal to 0. So we're going to subtract 2x on both sides. That will give us 0 equals x squared minus 3x. This isn't the normal kind of factoring problem. This is factoring with greatest common factor. So what do x squared and negative 3x have in common? X. So factor out an x. Then we need to solve. Now the x minus 3 is easy. What's the solution for the x minus 3 part? Positive 3, because positive 3 minus 3 would give you 0. So positive 3 minus 3 would give you 0. What value of x would make this first x equal 0? Think about what I just said. What value of x would make x equal 0? 0. So your two solutions are 0 and 3. Take a look at number 3. Step 3 says check the answers. You have to make sure that your solutions do not create 0 in the denominator of the original problem. So if we check 3, 3 squared minus 3 is not going to give us 0. 3 not going to give us 0. So we can plug 3 in there and be fine. What happens if we plug 0 in? 0 squared minus 0 is 0. If we try to plug 0 in, we end up with a denominator of 0, and that's bad. So 0 is an extraneous solution. 3 is our actual solution. I would like you to pause the video. Try number 2 on your own. The first thing that you need to remember is parentheses. You need to cross multiply. Distribute, get 0 on one side, factor, solve, check your solutions. When you FOIL and distribute, you should end up with x squared minus 3x plus 2 equals 6x minus 12. You need to get one side equal to 0, and then factor, and then solve. Your solutions are 2 and 7. You're looking for the two numbers that would make each set of parentheses equal to 0. So 2 minus 2 would be 0. 7 minus 7 would be 0. So your solutions are 2 and 7. Check both of those solutions in the original problem. What you're really checking for is, do either of these solutions create a mathematical situation that can't exist? Do either of these solutions make the denominator equal to 0? If we try plugging in 2, the only denominator that has an x is the second one. 2 minus 1 does not give us 0, so 2 is a solution. We plug in 7. 7 minus 1 does not give us 0, so 7 is a solution.